Here in this video we're going to take a look at how to calculate variance and standard deviation by hand. And I have the two formulas written. So variance, or s squared, is equal to 1 over n minus 1 times the summation from I equals 1 to n of xi minus x bar squared. And what that means is we're going to take all the difference of squares and we're going to add them all together and divide by n minus 1. And we're going to do an example to see how it all works. And then standard deviation is equal to s, which is the square root of s squared. So we're not going to recalculate it differently. We're just going to take the square root of our variance for our standard deviation. And then I have four numbers, so I have xi as 5, 11, 7, and 4. And what I like to do is create a little chart and do one piece at a time. So if you notice that we need the summation of all of our xi minus x bar squareds. So the next thing I'm going to do is create an xi minus x bar column. And then I'm going to create another column that is xi minus x bar squared. And in order to get x bar, remember that's the mean. We're going to add up all of our numbers and divide by the total number of observations we have. And here our n is 4. So we're going to have x bar is equal to 5 plus 11 plus 7 plus 4 divided by 4. And when we do this, we get 6.75. So now we're going to go through and we're going to do each column. So 5 minus 6.75 leaves us with negative 1.75. And then 11 minus 6.75 is 4.25. 7 minus 6.75 is equal to 0.25. 4 minus 6.75 is negative 2.75. And now we want to square each of these. And I rounded these numbers to 3 digits past the decimal. So here, negative 1.75 squared is 3.062. And 4.25 squared is 18.062. 0.25 squared is just 0.6062. And negative 2.75 squared is 7.563. And now what I'm going to do is total this column, because that's what the notation that says take the sum of all of the xi minus x bar all squared. That's what this column represents. So when we add this whole column up, we get 28.749. And now, since that represents this whole area, so this whole part of the function is represented by this. So now we're going to take that number and we're going to multiply it by 1 over n minus 1. So in this case, s squared is equal to 1 over n minus 1, or 1 over 4 minus 1, times 28.749. And when we do the math, we end up with 9.583. And then in order to find s, or the standard deviation, we're going to take the square root of s squared. So the square root of 9.583. Which is equal to 3.096. And that's all for variance and standard deviation.